Thank you everyone for joining and coming to listen to my talk. The title of this talk is There is no I in L. So if you were reading the agenda and you thought, wait a minute, is that there is no I in AI? Is he dumb? Like there is literally 50% of AI is I, right? There's just two letters, and of course there is I there. I'm not dumb. I tricked you into coming to this talk thinking this is a talk about AI, while in fact it's about L. You know, I even put the pronouncement here. This is not a talk about AI. We're going to talk about, we're not going to talk about agentic workflows, AI agents, or all these buzzwords that you hear. There will be a lot of Python code, and if you're more into AI automation and not so much into Python code, you may as well stay here. Like in 50 minutes, there will be a presentation from Angie about AI in automation. I'm sure it's going to be amazing, so you might just wait here until it happens. All right, let's get started. My name is Alex, and for the last 8 years, I am a Ruby maintainer on the Selenium project. Please raise your hand if you use Ruby. Okay, few people. So to those few people, if you've ever upgraded Selenium and it broke your tests, chances are that was my fault. I'm sorry about that. Nothing personal, it's open source, that's how things work. But I would love to chat to you about how amazing Ruby is after this presentation. Apart from my open source work, my professional career is just doing software testing. For the last 15 years, I have been doing software testing. I have written thousands of tests, worked with dozens of different applications. And I think, like many people in this room, quality assurance and software testing is where my expertise is. And for years, whenever I had to start writing a test for maybe a new project, a new product, I would pretty much always follow the same approach. So if, let's say I'm given an app to test, let's call it to-do, we're all familiar with it, where you can create tasks, complete tasks, remove them. And I need to start writing tests for it. I would pick up some test runner that I'm familiar with and I enjoy working with. It could be Cucumber. I know some people like TestNG here. For this presentation, I decided to just use unit test library from Python. So I'm going to pick up a library, that test runner that I'm happy with and that I'm familiar with. And then I'm going to pick Selenium. I'm going to start writing the tests where I would go to the application. And then I will pretty much use the page object pattern. I think it's kind of the standard way of writing tests nowadays. Please raise your hand if you use page objects in some degree. Yeah, majority people here. And then all this complexity of the UI would be hidden there. So then when I need to start writing the actual test, I would just call some methods on this page class. Maybe I would create a task. I would assert that this task is present in the page, and I would maybe add some assertion that task is created as a pending, it's not completed. And the test itself is fairly straightforward. It's elegant. You can read it. I can come back to it 6 months later, and I can understand what's going on here. Then, of course, I have to write the page class, right? It's actually where all the complexity is going to be. So I would need to start working on the public API on this page class. Maybe to create new task, I will locate some input, type the name of the task, press enter. To get the list of the tasks from the page, I would have to loop through all the list items on the page and get their text, and this is my list of tasks. And if I want to check for completion of the task, I would do pretty much the same, but this time I'll be just looking into completed tasks, and then checking if the test, the title we're looking for is there. So this code is no longer as elegant, as straightforward as the test. First of all, it requires specialized knowledge. you need to understand how Selenium works. You need to understand what API is there. It's tightly coupled to the user interface. You need to know what is the, apart from CSS selectors, it's just there's some assumptions on, of how the application behaves, that to create a task, you actually need to type it and press enter. And this is the code that very straightforward at this point, but it's the one that's going to grow. There will be maybe synchronizations added, some expected conditions, but all of that is going to live here. And at this point, my tests are ready. I can run them at fairly basic scenarios, but it's going to grow. And the overall approach will still remain the same. You have tests, you have some kind of support code, it's a page class, maybe some helpers, and then this support code is the one that is actually executed in Selenium. And in my experience, the support code is the one that tends to grow. So the tests are straightforward. They just called some page object APIs, but the page objects, the underlying helpers, this tends to grow. Start adding a hierarchy, base page class, special handling for asynchronous events, and I call it support code because it's the one that tests are using, but it's also the code that you support most of all. Whenever UI changes, you go there and you fix it. I go there and I fix it. Whenever something changes in the application, it's usually isolated within this support code. And I don't know what about you, but I don't like writing a lot of code. And I was always wondering, like, I have this elegant test, and I have this amazing Selenium, and I have this mess in the support code. Is there any way to get rid of it? And everyone is talking about this thing, AI. And I know it's not, I told you it's not going to be a talk about AI, but it is. And maybe AI can help us here. So everyone's talking about AI. I started looking for solutions. And I was looking, are there open source AI power tools that are specifically designed for testing that can help me with this problem? As I was researching, I basically grouped all the tools into two buckets. On one hand, we have test generators, and there are a lot of open source and paid products in this space. And the way they work is they expect you to have a test in a certain format. Maybe it's Cucumber, maybe it's some proprietary format, but certain format is expected. And then there is a tool, usually it's a command line tool, that will take the test, start the Selenium browser, and try to generate the Selenium code that will make this test pass. And once generated, it will dump it to you. You can copy it, you can download it, you can inspect it, you can run it. It's just a regular Selenium test at this point. So the test is literally generated. The test runner takes a different approach, where you still write a test in some format that the tool expects. And then when you run it, it's actually at this point the tool starts interacting with AI. It's going to be, starting the browser, taking some information from the browser, sending it to LLM, and figuring out what Selenium interactions has to happen for the test to complete. There are a number of projects in both categories, but ultimately, as I was working with them, I couldn't really, they were not fitting my use case because they all had sort of fundamental problems. They all expect tests in a certain format. For example, I was having hundreds of tests written with PyTest library. I don't want to use Cucumber. I don't want to add some new test runner in my application, in my test suite. I have maybe a library that parallelizes my PyTest across multiple machines. How do I actually start using it with some new format? I think that's just too much commitment at this point. All these tools work wonderfully well for new applications, but if you have a number of tests already, maybe you have helpers to create users, they have no idea how to use that. So they don't integrate very well with existing tests, and you can't just start start using them there. And they all make a lot of assumptions about the infrastructure that you're going to use. They will, for example, only start the browser for you. I don't want them to start the browser. I have Selenium Grid. I have things parallelized across machines. I don't need a different library to do that. So ultimately, I couldn't really use any of these tools in real work. So as a responsible member of open source community, I had nothing left but to create my own, which is called Alumnium. And it is an open source AI-powered test automation built on Selenium. I hope you really appreciate these PowerPoint style animations. I think it's great. So Alumnium, it's a tool that allows to simplify test code, not having you to write all this complex page object support code. This way gives you a way to reduce maintenance, because you just don't have that code. You don't have this code written in the first place. You don't need to support it. And it's more robust because there is no code. Less code, less points of failures. This is kind of marketing, right? But what essentially Alumnium is, it's just a Python library that provides an AI-powered API for Selenium. And it's very compact, and it gives few methods, just a few methods. And then you use these methods to combine and execute your tests and to kind of interact with the browser, interact throughout the test execution. So you can do actions on the page, you can check for verifications on the page, and you can get data from the page for your assertions or for further test execution. And then you just use these methods like any other Python code during the test execution with the test runner or library you like and happy to work with. Okay, let's take a little bit closer how that looks like. So Alumnium Do is a way to perform actions on the page. So you literally tell Alumnium what you want to do on the page, and it figures out how exactly to do that. So you can tell it to create new task and give it the title of the task, and then Alumnium is responsible to figure out, okay, this is our page, there is an input, so I probably need to type, press enter, and that will create the task. Or you can maybe say that the task needs to be marked as completed, and Alumnium needs to figure out, okay, there is a checkbox, so I probably need to click the checkbox. Likewise, if you want to delete the task, the exact interactions within the browser is something that L figures out for you. Alumnium check is a way to verify conditions on the page. And again, you tell what must be true, and Alumnium figures out if it's actually true. And you can say something like, I want to check that some task is pending, some task is completed. And in order for this check to be successful or not, Alumnium has to understand what is actually a pending task. So maybe there is a task and there is a checkbox, and the checkbox is not checked, so that's probably a pending task. And then there is another task which has a checked checkbox, and that's probably a completed task. So in either event, it tries to figure out if this statement is true. Otherwise, it would throw assertion error. Last but not least is get, which is a way to extract data from the page. Again, you tell what you need. Alumnium figures out what's based on the page contents, what's there. And the information you can try to get is not necessarily within a single element. It can spawn across multiple elements. It can actually be not presented in a direct manner on the page, but it can be inferred. Like if you want to say, give me a number of tasks on the page, then Alumnium can give you like number 2, which is an integer, because there are 2 tasks on the page, even though this information might not be specifically mentioned. Or maybe you can ask to give you the titles of the task, and then it will return you an array of strings. Or maybe you want to be more concrete and say, just give me titles of pending tasks or completed tasks. And again, it has to figure out what constitutes a pending or completed task. So that's pretty much it. Like, there is a little bit more in the library to that, but these three methods are what you use within the tests to drive the execution. So let's go back a little bit, and where we stopped in our example of to-do app, we had a page class, and we had a test. So let's try to change it and see how it would work with Alumnium. So first of all, we go back to our page class. Well, as I said, we don't need any of the support code, so we're just going to remove all of that. We don't need page class anymore. Now, obviously, our test is failing, right? So how do we fix it? We start by replacing the page class instantiation with instantiation of Alumnium. So you can see we just instantiate a class. We give it an access to our driver instance. There is nothing more. It doesn't start the browser for you or do any heavy lifting. It just you're still doing all of that. You're still in control of that. So how do we fix the test? The first line where we create a task, well, we just literally tell Alumnium create new task. It has to figure out. If it's not going to figure out, the test will fail, and then you can iterate over it. How do we fix our first assertion? Well, we just need to get the titles of the tasks, and we're still going to check that our task that we just created is there. And again, if Alumnium returns something that makes no sense or the task is not there, the assertion will fail. And last point is where we check the task is pending. Again, we replace it with just saying check the task is not completed. And that's pretty much it. This is literally all the code for the same task to pass. There might be like import statements, which I omitted, but from the rest, it's all the code you have to write for the same task to be passing. So let's go to write and support. I think that's good. You can see how you can use this library within the existing tests because it's just a Python library. You install it like any other library, and you just instantiate the classes. There is nothing else except for that. And unlike many tools, you are actually in control of everything because you're not committed to start using a new test runner. You can actually install it, maybe use it in a couple of tests, maybe replace part of your tests with this, see how it works, see how stable, how fast it is, and if you're not happy, you haven't invested a lot of time or effort into this. And of course, it doesn't require any new infrastructure. You can still use it with the same test runners, CI/CD systems, test reporting tools. There is nothing that is there, well, with a small exception that, of course, there has to be some kind of access to AI provider. So let me talk a little bit about that. The way I was designing Alumnium from the very beginning, that it has to support all the major AI providers. This is the three major providers that Alumnium currently has: Anthropic, Google Gemini, and OpenAI. It works on all of those. So if you want to play around with it and your company is using any of this, we have it. And it takes an enormous amount of effort to actually make it behave exactly the same on all these platforms. If you've ever worked with LLMs, you know how inherently different they are. And Alumnium, we have CI, where we run a bunch of tests for every single LLM, and we make sure that it behaves exactly the same. There, it's very complicated, but my point is that wherever you choose among these three, it's going to work. And then maybe at this point, if your company uses them, great. If not, and you maybe have concern about the privacy, okay, like, I don't want the tool to send information from the browser to any of these providers. I have no idea how they're going to use this data. That's a fair point. So Alumnium also works on open weight models. Llama and DeepSeek are the two that are currently supported. And I'm actually started working on Gemma 3 because it satisfies all the properties. But yeah, you can deploy Llama on your infrastructure. You can deploy DeepSeek in your infrastructure, and then you can use it with Alumnium to make sure that no information is leaving your infrastructure. So yeah, there are options to be cautious in terms of privacy. And then the next thing you might be thinking is that LLMs are expensive, right? You're sending some information from the browser, how much that's going to cost. And that was my concern from the very beginning. And the way I've been designing this thing is it has to work on the cheapest model possible, right? So all the providers have their amazing frontier models like O1, O3, which are super smart, and they're also extremely expensive. And my idea was that I don't actually want my tests to be so smart. I want them to do what I tell them to do. If they can't do it, just fail. Don't try to be super smart. So all these providers have these low-tier models, which are still very smart. They're very fast, but they cost just a fraction of their frontier solutions. Like Anthropic has Haiku, Gemini has Flash, and OpenAI has mini models. And they all very, very cheap. And to kind of give you a perspective how cheap they are, we ran a bunch of tests on CI in the Alumnium project, and I was checking the bills, and it's costing roughly $3 per 1,000 tests for Anthropic and OpenAI. So you can try to extrapolate that. If you have 10,000 tests, they're going to be $30. If you run more than that, it's going to be kind of 300 for 100,000. But I think that's cheap enough, because if I were to come to my manager and say, hey, I have this amazing tool that allows me to stop writing so much code, and we're going to pay a few $1,000s per month for it, he might as well say, well, let's fire you, because why do we need you? We're just going to pay for this. I don't want to do that, I think. So I really wanted to build this so that it's dirt cheap. Like paying $10 per month is no big deal from my point of view. Yeah, so I think we're at the point where we can do a demo. And I'm going to try to do a couple of examples. I hope my internet works. So the first example I want to show you is tests for a calculator app. So let me just open it. And I really hope it's going to open, because otherwise I have to show the recording. It's no fun. OK, this looks like I'm going to have to show the recording. OK. Let it be. All right, so we have tests for a calculator app. This is just a regular calculator. You can do operations, click it, you know what it is. And then we're going to have a test for addition, for subtraction, multiplication, and finally division. And in all these tests, what we're going to do is we're going to tell Alumnium to do something like 2 + 2 equals. We're going to get the result from the calculator, and we're just going to assert with what it should be. And I want to thank Jason Huggins, who proposed this idea of having a calculator as like a basic litmus test for AI-powered tools, and Michael Mintz from the Selenium's base project, who actually created the calculator. So you've seen something was happening there, like some clicking, and the tests are passing. And now we can maybe change the test so that it fails. Let's do 2 + 2, and then assert that it's 5. And you can see that there's an assertion error, so it's fairly straightforward. The second example I want to show you is a bit more complex. It's a SOSDAMA application, where it's an internet shop where you have to log in first, and then you see some products on the page. You can add them to the cart, like 1C and backpack. You can navigate to the shopping cart. Then we're going to run some verifications, take the titles of the products in the cart and assert that this is what we had. Then we can go through the checkout, fill some fields, run some assertions for what's the item total without tax, what is the tax amount, what is the total amount. This is all information that will be shown on the page, along with shipping details. And we're going to finish the checkout, run some checks, that there is a thank you message, and then there is this big Greek check mark. You can see there is this extra thing called vision true, which actually tells Alumnium to use a screenshot, because that's an image we need to assert based on the image visuals rather than just text information in the browser. So yeah, you've seen, I hope you've seen, it's kind of quick, and it's not so visible on the screen. But yeah, we had the test pass in, and you've seen them clicking around. And if we change the verification from the big green check mark to big red check mark, it's probably going to fail. Well, it's going to fail because it's recording. And you see some filling information happens. There is like, assertion error, and then you can see that the test has failed, and it says it's not red, which is correct. All right, this is it for the demo. Alumnium is very, very early stage project. It's just a few months old, and there is a lot to be done there. And the very first thing that we're working on is to make sure it's scaled to very complex web apps. So it works great for simple things like small internet shops, calculators, to-do apps. It doesn't work as reliably, as fast, and as predictable for big things like Amazon or YouTube. We know what to do there. We know how to scale it. It's just a matter of getting it done. Performance is something that is critical in testing, and you can see this on this slide, or maybe I hope you see it. But like, if I've written 10 tests for the to-do application in Selenium, they run for 3 seconds. Alumnium runs for 50 seconds, which is extremely slow, right? You can't afford that. And again, it's something we work on, and of course the obvious answer to the performance problem is caching, and with caching enabled, we get the numbers that are closer to Selenium. With enabled cache, Alumnium runs the same tests in, again, 3 seconds. We are to add support for Firefox and Safari. Internally, the way Alumnium works is by using accessibility tree, which is not available natively in any browser except the ones that are based on Chromium. So Google Chrome, Microsoft Edge, and Opera, they all work, but Firefox and Safari does not provide a way to get this information from the browser, and this is something we are yet to solve. Likewise, support for mobile platforms is something we need to work on, and conceptually, again, there is nothing that would prevent the same API, the same approach to work on iOS or Android, as long as we have a way to understand what's actually present in the application. So maybe in a year or 2 years, we'll meet again, and I'll be happy to share that it works on Appium. And last point is that it is just a Python library at this point, but in the spirit of all the projects like Selenium and Appium, we would like to have support for other languages, Java, JavaScript, and Ruby, which I personally enjoy most. This is something that is coming. Again, it's very early stage project. It's open source, MIT license, and the best thing you can do to support the projects, if you're even a little bit interested, is give it a shot. See what kind of issues you run to, report them to our GitHub project. You can come to the Discord channel, Discord server, where you can complain things not working because they won't. And if you're already on the Selenium Slack, we actually have a separate channel called Alumnium, where I would be happy to answer any questions. and explain a little bit more how it works, why it works, and why it's not working for you. So thank you very much for having me, and yeah, thank you.
Thank you, Al, aka Alex.
Yeah.
There you go. Any questions, folks? All right.
It's a great presentation. I have a question regarding the LLM. So is there any idea to accustom it to custom LLMs? For example, in my company, we have a custom LLM that was developed by my company. So if I want to integrate it with that LLM, is that possible in future?
Yes, it is possible for sure. So there are a couple of expectations. So any LLM that is being used by Alumnium needs to support visions if you need vision support.
Okay.
And it has to support tool calling, and that's it. Other than that, you can plug it in with anything, and how well it's going to perform is to be determined, because all the models behave differently, but there is nothing that technically would prevent you from. It's just that if you have some kind of open weight models or model based on open weights, it's just that in my experience, Llama and DeepSeek behave best. But if you have something custom, yeah, you can use it for sure.
Even now we can use it with the current thing?
Yeah.
Okay.
It might require some changes, but just raise an issue on GitHub and we'll figure it out.
Okay. One more question. So you were giving the commands, right? So create this task or create some user or something like that. So how were your test results? So I mean, like, for example, if you're running 100 tests, so how much LLM is understanding the things that you are writing over there?
You mean, is the question like how accurate it is?
Yeah, correct.
Okay. So we have CI, and it's actually not failing. So we run the same tests over and over with Anthropic, with OpenAI, with Gemini, with Llama, and as soon as the test fails, like the whole CI builds fails. So I know that many AI projects are measured in benchmarks. Like we have 90% accuracy. I'm like, yeah, which means like 90% of the tests are going to pass. It's not good, right? So the goal for Alumnium is to be closer to 100%, and we're pretty close to that, at least in this scenarios that we have. And I hope as more people start using the library, we'll have more examples. Things will be breaking, and we'll be working on the project to make it work.
Okay, thank you.
But like for February, we were running CI, and there was no failure. So that's pretty good for me. Good enough.
Just a quick clarification, since you mentioned vision. Does it have to be a multimodal LLM, or it has to be?
So it doesn't have to be, and by default, it's not using screenshots, vision. It's just that if you want to run some verification that really needs screenshot, like you want to say, if you go back to an example of this to-do app, and you want to say that the buy bread font style has to be strike-through, you can't get this from the text. Like you have to visually see that the font style is strike-through. So in this case, you would use vision. But if you're not tied to that, it doesn't have to support multimodals.
Thanks. All the way back. Okay.
Hi, thank you for the awesome presentation. I really like the idea. And specifically because I really like the idea, I have the following question. How do you ensure the quality of your solution itself? In other words, I, as a user of your framework, how I can be sure that I'm testing the correct thing and I'm testing the thing correctly. and not getting like the false positive results all the time and be like pretty happy with the 100% passing rates?
Yeah, so the way I approach this is by using LLM just for things it could be helpful. Like if I need to extract data from the page, I would use Alumnium to do that. But the actual assertion happens in the client code. So if Alumnium gives you some gibberish or nonsense, the test would still fail. And the failure of the test indicates that something is wrong. So by having that mindset, like use tool to extract the data, but actually verify it manually, gives you the great level of detail and the great level of precision. If your test has done something wrong somewhere in the middle, it will eventually fail. And that's how you guarantee that the tool works correctly. We run CI, we run the same tests. As long as the tests are passing, we're good.
Okay, thank you.
Any questions?
Yeah, in terms of performance, that's mostly my objection to these kind of tools. Have you considered asking the AI to write it and then run the code itself instead of constantly re-asking to generate the scenario?
So this is, if we were to ask LLM to generate the code, and then you just commit it and run it, this is essentially a test generator. The problem with this approach is that once your application changes, you have to regenerate the tests because they're now failing. And it's kind of, I think, a little bit broken loop. And I think a better approach is you ask LLM how to do that on the page. And if it's possible, you actually catch that. And you keep doing the same thing until your application changes, at which point you automatically ask LLM, hey, once again, how do I do that? And caching on this level is going to be very hard, so you have to make sure, like if your maybe class has changed, it doesn't have to invalidate the cache, and which is why Alumnium uses accessibility trees, because they are very compact. They actually just take into account what's visible on the page, throwing away all the noise that is present in the DOM tree. And it works pretty reliably and pretty fast.
Okay.
And there was one, yeah.
Hi. As I understand, behind Alumnium, we have pure Selenium. And do we have any log of Selenium steps? So clicking, finding elements, which method was used, CSS selector or XPath, or do we have for debug purpose?
Yeah, there is a log file which you can inspect, and it will actually tell you exactly what you asked, what it figured out it needs to do, which elements it would need to click, what type. So this is all in the log file.
Okay, great. And second question, because this do and I forgot the second
check.
Get, right?
Yeah.
It's similar to given when then in Cucumber, for example. When would be for do, then would be for get, for assertion.
Okay.
Is there any integration planned for BDD?
No, I never really thought about BDD. So my goal was to have a library that just have API. And if you use Cucumber or BDD, you can just use it like you use Selenium. You can, if you use PyTest, you can use it like you use. So I don't think it has to force into particular integration.
Okay, we can take one last question.
You mentioned that it looks at the accessibility tree to do a lot of the inference. How does it deal with an application which isn't sort of in a pristine accessibility, like a real world example. Like if anyone uses accessibility tools, most apps and websites aren't in sort of compliant condition. If they have any data at all, what's the performance data look like for those kind of situations?
So, great question. Normally, it's fine because the way Chromium works is that it's going to give you something, like if something resembles a button and is clickable, it's going to tell you this is a button. This is what it's also given to operating system. If you have an application, and it doesn't have to have any accessibility roles or labels, anything, because the browser will actually give that to you by kind of, I guess, inferring what's being painted. But if you have an application that is like purely canvas, it doesn't work. So, because there is nothing there except for images. So that's a limitation.
A round of applause for Alex. Thank you, Alex.
Thank you.